Hello everyone and welcome to the demonstration video. In this video we're going to go over recursion. In one of the discussions or the announcements for this week, I did mention how you basically have most of the building blocks for creating simple programs with Java. So you've learned about loops, you've learned about variables, you've learned about functions, and you even learned about arrays. So you could go ahead and basically implement, you could look up different algorithms you could try to implement with Java, and you have the tools in front of you to do that. So, if you can think of something, you could go ahead and implement it. But from here on out, we're going to get all of those building blocks and build upon them. So we're going to be talking about different other programming concepts that are also used within the industry itself. So these are used within the industry, and you'll be learning how they work, why they're used, and how to implement them. So our first dive in is recursion, which seemingly it can be a hard concept to grasp, but once you get it, or at least you somewhat understand it, you'll know how to utilize it. Okay, so with the recursion, just know that this occurs with functions, or remember we call it methods. So functions, methods can be used interchangeably, but recursions occur with functions itself. And you could think of it as like creating a loop. So I'm going to use the quotations, a loop with functions. So think about it. Every time you call a function, let's say, like in the case of this video, I'll be using the factorials as an example. So if we create a function which returns an int factorial, there we go. So int factorial, and we know it has to take in some kind of value to actually go through with the factorial. So we'll do the parameter int n. There we go. So we have this function. And remember, if you call this within your main method or even in another function, a separate function, you're kind of copying and pasting this code over. The only thing is that the variables are separated. But if you copy and paste that code over, what would happen if, let's say, you call factorial in here? So imagine that in these parentheses, you have some kind of number. There we go. And you call itself in here. So you're basically having it copy and paste itself into it. Maybe you just have or actually you will have a different value within your arguments. So that's the idea we're going for. So if you go through, let's say this is one number and this is another, it creates kind of an instance inside of itself. Now the best way I could actually visually show this is with my recording software itself. So let me go ahead and bring this window in. So I use OBS, and it looks a little something like this. There we go. So this outer part right here is actually my main control for recording. You can see I have my record button, all of my setup is here. And within here is the preview of the screen I'm recording, whatever video, even if I have my camera on, it'll be here. And you notice it's copying itself because now I'm recording a video of the software itself, and you can see that that box is in here. This part is still recording the part within it, so it's in there, and it goes on and on and on. So you can think of recursion as this way, where this main part out here is the function you initially call. Then when it calls itself, so if I go back here, if it calls itself, then it's inside of here. It's inside of this box, and it has its own parts that it could manage. And if it calls itself again, you get a box further and a box further and a box further. So if you want to think of a more visual way to look about it, think about recording the camera of the screen of the camera recording. Or in my case, recording the screen, that's recording the screen. Okay, let's get this out. Perfect. So the reason why I use factorial, and you've probably already seen a video using factorial for this, is because it's one of the more simpler ways to see how the problem is broken down. Okay, so let's actually go into the factorial itself. If you don't know what factorial is, just know that if you've done some kind of, if you got into this point of math, let me undo that, there we go. You'll see a number with an exclamation mark next to it. This means 4 factorial. Factorial is a type of calculation you can do. So when it comes to factorial, that just means multiply 4 and all the numbers between 4 and 1. So that would look like this. 4 factorial is 4 times 3 times 2 times 1. And let's pull up a calculator. If I have a calculator. There we go. And I don't know if I have factorial on this. Do I? Yes, I do. So this button over here, the N with the exclamation mark, that's a factorial for the scientific calculator. So if you want to test it out on your own, make sure you find a scientific calculator. Okay, so if I do 4 factorial, you see that it gives me 24. Okay, so we know that that would be 24. Perfect. So this is what we're trying to implement with our factorial function. So if I go over here, let me organize this real quick. Okay. So if I go here, I already set up my program where I'm going to go ahead and it'll go ahead and loop until I put in -1. This is so that way we could test different inputs. So just know that's what I'm doing here. And actually, let me do it where it's here. So we're going to go ahead and say system.out println. We're going to ask for a number of factorial. So it's going to be input new number. Parentheses will put -1 to quit. There we go. And formats it with a colon. Perfect. And then we'll ask the choice. We'll get it in with the scanner, so std in. This we're getting an integer, so next int. So this is just me setting up my loop. Okay, and if it's not -1, so if choice does not equal -1, we're going to output the factorial. So we're going to go ahead and say here. We're going to call the choice, so we're going to put in the choice here, factorial equals, and I'm going to concatenate whatever the function factorial returns for choice. Now notice we still need to make that function. So in order to make that function, just like how you did with the previous assignment, you'll go ahead and set it up. So in this case, public static, not void, because remember we want to return an integer directly. So we're going to say int, say the name of our function, so factorial. We're passing in an integer, so we want int n. There we go. And right now it's a little angry because we're not returning anything. But we'll get to that. So just know again, if we're doing recursion, it has to be a function. It has to be some kind of function we're utilizing. So the first function call is here. Now, how exactly do we know we could implement this recursively? Because remember, to do a recursion, you have to have it call itself. So let's take a look at how the factorial works on its own. So what we do know is if it reaches 1 factorial, so if it's 1 factorial, that returns 1. So it's just normal 1. The same thing happens here. Let me actually go ahead and put it over here. So 1 factorial is always equal to 1. So we know that for sure. 0 factorial, so 0 factorial also returns as 1. These are things that we definitely know the value of. Of course, here we could see like a definite calculation, but these we know that, hey, once it reaches 1, so the smallest version of the problem, 1 or 0, it will return 1. So we call this a base case. Let me go ahead and do a base case. Typically how you detect a base case, so we call this the smallest version of the problem. So I'm just going to notate this, small v of problem. So the smallest version of problem is going to be considered your base case. Why this is important is, remember, we're thinking of this as a loop. A loop has to end. If I just call factorial n within itself, it's going to be a recursive loop. And we don't want that. We don't want, well, a recursive loop we do want, but a recursive infinite loop is not what we want. Remember, if your while loop is going on, or even your for loop's going on, it could mess either with your computer or the program itself. So just know you do need what we call a base case, which has the loop stop. This is the smallest version of the problem because notice, no matter how high the number we go, it's always going to decrease to 1, or in some cases 0. Sometimes you have a 0 factorial, so we know that that's going to be the base case. Whether it's 3 factorial, that's 3 times 2 times 1. There we go. So it always ends at 1. So that's a way in which you could detect a base case. See what is consistent between all your problems. What is the smallest version of that problem? What's the smallest you can get it to? And at that point, it's going to need to stop. So you have to detect your base case. Now we need something else called a recursive case. Let me go ahead and write that here, recursive case. Now your recursive case, here, let me do, this is one step you need, find your base case. The next step, find your recursive case. This means what condition do we need to have in order to call the function itself? So how do we get it to where we call the function, and what do we need to put in to get the function smaller? So remember, if you keep returning n, it's going to be recursive. It's going to be an infinite loop. But if we change what's given into the input, into the argument, then you can make the problem smaller. So recursive case, basically think how to make problem. So how to make the problem. So how to make prob smaller. So that's what you're trying to think of when you're trying to implement a recursion. One, when does it stop? What's the base case? What do we need to look for the base case? In this case, we definitely know at 0 or 1. If n is 0 or 1, it's going to return 1. Okay. Recursive case, we need to know how to get it smaller. So notice, if we look over here, we definitely know that the number's decreasing. Perfect. But we still need to know that we're working with the factorial itself. So if we're calling factorial, that function is going to be called in it. We're not calling multiplication. We will be using multiplication, but we're not calling a function called multiplication. We're calling a function called factorial. So we need to find we have to actually implement factorial into this process. Now, knowing how factorial works, look up here. 3 factorial equals 3 times 2 times 1. Which, if we look at this, well, let me actually use a blue. This very much looks like this part. So if we break it down, 4 factorial can actually also equal 4 times 3 factorial. And if you keep on going down, 4 times 3 factorial, well, not 3 factorial, but 4 times 3 times 2 factorial, there we go, because 2 factorial would be 2 times 1. And then 4 times 3 times 2 times 1 factorial. And notice you got it to the base case. So that's what I mean by breaking it down into smaller problems. You have to get it to the base case, or at least get it to some kind of condition that will meet the base case. And then at that point, that's when the function stops. Now, one thing you need to know about base cases is that will return a definite value. So in this case, we know that our function would return 1. As for a recursive case, that has to actually either, if you're using void, you could go ahead and just call the function, but typically if you have a function that's returning a value, you're going to go ahead and actually call the function itself with the return value. So in this case it would be factorial. So we definitely know factorial. Actually, before we even get to factorial, looking over here, you get the number you're currently on. So that would actually be n. So it's n times, then we're calling our factorial. There we go. So our factorial, so it's calling itself. And to make the problem smaller, instead of passing n here, we're passing n minus 1, because we notice we're always decreasing by 1. Okay, so if sometimes you do need to think about recursion in this way. This may seem like a long roundabout way. You may even wonder, can't I just implement this as an array and a loop? And yes, you can. But recursions can help with just reading in general. A loop and array, although implementing it may be a little easier and logical for you, but here, looking as a recursion, you could break the problem down further. You may save yourself some time and even some reading. When you're reading your code, it could be very obvious with a recursive method that, hey, we're just breaking this problem down further and further. And this is how it's going to end, and this is what's going to return. So enough of planning it out. Let's go ahead and actually implement this. So based on what we know here, remember we have to do a base case, then a recursive case. Okay, so at least with the factorial method, let's go ahead and do this with Java. Doing the base case is pretty simple. Typically, again, if you're trying to do the base case and recursive case, you're always going to use some kind of if-else statement or if statement. So in our case, we're going to say if n equals 1, or, so we're going to be using or here, and that's with these two lines, there we go, vertical lines, or if n equals 0, there we go, then it will return 1. There we go. Notice it's still a little angry with me. It wants a return statement outside. So let's go ahead and give it that. It could be a recursive case. Now you could say if, you could do this in reverse. If n does not equal 1 or does not equal 0, you could say do the recursive case. But here I'm saying the base case. If it's that, return 1. If not, so that means it's 2, 3, 4, and above. You could say return n times, and then call itself factorial, and remember we're trying to get the problem smaller, so n minus 1. And then this will calculate as n as 1 smaller than what n is, then pass it through, and it calls itself again until it reaches 1 or 0. Perfect. So let's go ahead. Let's go ahead and run this. Okay, so input a new number. We're going to say 1. So we're testing the base case. 1 factorial does equal 1. Perfect. Input a new number. Let's put 0. 0 factorial equals 1, which is true. There we go. So we know our base case is working. Now let's go ahead and test for any numbers larger than it. So 6 factorial, it says, is equal to 720. Let's try it here. So 6 factorial, there we go. It is 720. Let's try here. Let's do our 4, which we knew was 24. There we go. And you see the factorial is working. We're not using any loops. Actually, in this case, it was just basically 3 lines of code, as compared to having to implement this with an array and with a loop. So notice recursions can take some planning, actually quite a bit of planning to implement. But let's say, especially if you're a mathematician, something like this can be very intuitive and you could go ahead and implement it real quick. Let's go ahead and exit out of this. -1. There we go, and it stops. So if you're implementing a recursive function and you want to, let's say, there's something that's not working as you would like it. There's some kind of bug. Debugging your program, we went over a discussion about debugging your programs, does take a lot of you having to go through your program line by line and kind of executing in your head, seeing what exactly is going on. Now typically, here, I'm going to go ahead and erase this, give you a moment to look at it, and now it's going to be gone. So how I recommend debugging is keep track of your variable values. So if you're going line by line, know, okay, I have a scanner that exists here. So you could say the scanner, and then indicate the name. There we go. You could jot down some other information about it, but just know that at this point we have a scanner existing. You also have an int choice that exists. There we go. Int choice. Okay. So when we go here, you'll know, okay, int choice is set to 0. So that's something that you have to keep in mind when debugging. So not just when the variables start existing, what values do they have at this moment? So we know it's set at 0 because we said equals 0. We assigned it 0. So now when you come across a line like while choice, so we're calling the variable, does not equal -1, you'll go back. See, okay, int choice. Here, let me see, can I do this as a side by side? Yes, I can. There we go. So if you see that choice equals 0, it does not equal -1, then you step by in your head, okay, so it's going to start executing this. It's going to start executing what's within this program, because 0 does indeed not equal -1. Since that's true, it'll go ahead and do the loop. Print this out, give a choice. In your head, maybe you could give it some kind of choice that the user would input. So you could cross it out and say, hey, the user is going to input 2. It goes down here. Again, you're checking, does choice, so 2 not equal -1? That's indeed true. So it's going to go ahead, system call, print out choice, so we know that's going to come out as 2. Then factorial 2. So this is where it gets a little trickier. If you're working with functions, I recommend separating your whatever you're jotting down for the debugging. So now that you're going to have kind of like that line, this is for everything within main. Here, so we're going to say that this is for main. And on this side is going to be stuff for factorial. So now we know in factorial, Since we passed through choice through this parameter int n, now we know that there's an n. Oop, remember we want to know the type, so int n. We passed in the value 2. So just choice directly 2. So we know that equals 2. And now this is where it gets a little tricky. So we have 2. So int n equals 2. We know that 2 does not equal 1 or 0, so it will not return 1. Okay. So now we look over here, return, I would say jot this down. You could say it returns, or just say return, do in your head, 2 times, and we know, oh, there's another factorial, so we're actually going to go ahead and create a new instance for that. So separate your functions, a new factorial, there we go, where that n, so the n for that factorial, int n equals, notice what's passed down, n minus 1, so that's 2 minus 1. So that equals 1. So now when you look at it here, we're going to go through this iteration. So remember, it's kind of like a loop. It goes in on itself. This is now 1. Then we check. If n equals 1, that's true. So now that's going to return 1. So that returns 1, then you could go ahead over here and say, hey, this is 1. So 2 times 1 is going to be returned. There we go. So if we go over here, and now we know, thinking back to it, 2 times 1 is 2. So this is now, well, this is still 2. And that's what will be outputted over here. So when you're thinking about factorials, debugging, you do have to keep track of all of these different instances. If you can't do it within your head, that's okay. Go ahead and draw it out just like how I did here. This method is very valid. You could go ahead and, in my case, I did it with MS Paint. Drawing with a mouse is very difficult, so you could either jot it down on a piece of paper, keep the separation, keep track of where you're going. Some people have used whiteboards. I did see a discussion of someone mentioning how they use whiteboards, and I think that's a very nice tool that you could use. I myself have a handheld whiteboard, and you could go ahead and look into some whiteboards for you to use as well. So I do recommend that with your programs, especially when it comes to debugging. Make sure you're reading through those discussion boards about debugging, as it is a crucial thing for programming. It's okay if you are not the best with logic. It's okay if you're not the best with math. But at least the problem-solving process is what you're going to get from this course. So in this case, debugging, going through, testing this, and coming up with fake scenarios. So not necessarily by running the program, but going line by line and seeing how it works. Especially with recursion, as we see, it gets a little more trickier. So that's why I do recommend you writing it out, see how it works, break that problem down. But that would be recursion. One thing I could show real quick, so let's go ahead and, here, we'll just comment all this out. I did provide videos of other problems that can be implemented recursively, but just as a more simple problem that I could show right here is you could even do something as simple as a countdown. So this will be void. We're going to call this function a countdown, and it's going to still have a int n. There we go. So we're going to have this countdown from a positive number, so some kind of number, all the way down to 1. So you could take this moment in the video to maybe think about how you would implement this. So go ahead and start the planning process on whatever whiteboard or paper you have, and think about how you could implement something as simple as a countdown recursively. So no while loops, no for loops, just with the function itself. Okay, so let me go ahead and here, so if we call countdown over here, let's say 10. Now, at least me, I could do this in my head, so I'll kind of show it to you with my own thought process. Is if I have some kind of countdown, I definitely know that it has to end at 1. So my base case has to be 1. I want it to print out 1 and then stop at 1. So I know my base case here would be if n equals 1. I'm just going to print out, so system.out println. I could either just print out 1 or just n itself, because n is going to be 1. There we go. Now as a recursive case, kind of like how we just did with our factorial function, we know that a countdown, it decreases. So it just keeps decreasing. So we definitely know that we could just call the countdown itself n minus 1. But we have to make sure that it prints it out first. So remember, we still want to print out n. So system.out println n. And then we'll call, not factorial, but the countdown, n minus 1. There we go. Now I'll get to something in a moment, but if you take a look at this, we could try doing it in our head. I'll go ahead and just run it. So this should go from 10, so remember we passed in 10, to 1. It should print it out. And it seems like I actually came across my own loop. So let's take a look here. Let me go ahead and terminate it. So that was an infinite loop. Now we need to take a look at what actually went wrong. So let's do some debugging. So the if statement is still going to print out this. So if we get to 1, it's going to print out 1. But it's still going to print out the other stuff. So it's still going to print out itself again and the countdown. So in this case, it would actually be an if else. So one or the other. Remember, knowing your building blocks is going to be important. So now if we run this, we have a perfect countdown: 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Even if we change this to 30. Oh, let's save that. There we go. Run it. 30, and it counts down to 1. Perfect. So that's some quick debugging for you for a countdown. But do know that it could be implemented in this way as well. Here, it didn't have that issue with return, because when you return something, it stops that function. So like in the base case here, it returns 1, it stops. It doesn't go past that if statement, it'll stop at the return statement. Down here, since we're working with void, we do have to do an if else. Otherwise, it's going to be infinite, as we saw before. So this is one way to implement it. Actually, another way is, notice how, so this is a bit of just small refactoring our program. So refactoring just means making it kind of either look better or even work a little better. So notice, we're copying system.println here. So it seems like in either case, we're doing system.println. So let me go ahead and just take that, put it over here. So if we replace those two with just system.println, we don't need this entire if-else statement. Actually, we can just say if n does not equal 1. So if n does not equal 1, there we go. Let's get the countdown, and then we'll do the recursive case. So sometimes your base case and your recursive case kind of combine in this way, where we say, okay, so as long as it doesn't reach the base case, then you repeat it. So this will still do the same thing. So let me clear this so we can see that if I run it, there we go. It still goes from 30 to 1. So that was a very basic way in which we could implement a countdown recursively. So without even a while loop or for loop, although that's still as quick as that, but you can implement that recursively. Almost anything that you can implement as a loop can be done recursively. You're just going to have to do the logic behind it. For instance, here we accidentally had an infinite loop. You're going to want to make sure you avoid that. So that is recursions. Again, if you want to see bigger examples when it comes to breaking down the problems, you are going to have to go ahead and you can take a look at those videos I have provided with different problems that can be solved recursively, how it's broken down, and kind of a little bit of how it can be implemented with code. But your biggest thing is going to be how to break it down. So make sure you have that process. If you would like to go over it more, again, I have my student hours, and we could always schedule a separate meeting. Now, with your assignment, again, it is a bit more of a complex problem from just n minus 1. But just remember, figure out what your base case is, so when is that program stopping, and how are you going to get it smaller? How do you chop it down further? You're going to be working with money. Remember, you're breaking down cash. So what's the smallest amount of cash you could have? So when do you stop when it comes down to, let's say, returning change to someone? And then how do you know how that problem breaks down further based on that change, those bills that you're giving out? That's a little bit of a hint, but I will leave it at that. All right, thank you for joining this video, and I'll see you in the next one.